All right, today we're going to talk about lesson 2-7, which is going to deal with rational numbers. All right, there are rational numbers and then there are irrational numbers, and it has nothing to do with their attitude or their behavior in general public, okay? Unlike middle schoolers, where you have rational middle schoolers and irrational middle schoolers where you're not exactly sure what's going on, which is most of the time. So we're going to talk today about rational numbers, and let's go ahead and dive in. All right. A number that can be written as a... What do you think?
Decimal.
Open up your textbooks. Take a look. Rational numbers. Okay, William. A portion of... Is it portion?
Quotient.
A quotient of... Two integers. Okay. A quotient of two integers. Now that means, what's the word quotient suggest? It's a very fancy word that means what? Okay, Jack.
It has the answer to a division problem.
It's division. So basically, it's a number that can be written as the division of two integers. Okay, so quotient kind of implies division. All right? Or, and this is going to be an even better definition, a number that can be written as a... Yes.
I didn't get notes. The note page.
Okay. Please get one for him, Dallas. What can be written as? No, not as a decimal. Okay? Yes.
Mixed number?
Yeah, well, that's very close. A fraction, which somebody here said as well. All right? That's excellent. If you can write it as a fraction, it's rational. Okay? So, here are some examples. They can all be written as fractions. So, 2 over 5 is already a fraction, so check. 3 repeating. What would that be as a fraction? Yeah. 1/3 or 3 over 9 simplified to 1/3. We talked about yesterday how all repeating values get put over what? Over 9s. Okay, so check. And then -6, how can that be written as a fraction? Yeah. -6 over 1, that's right. -6 over 1. Check. All of those meet the criteria, okay? So big check marks because they all can be written as fractions. So repeating decimals are rational. Negative numbers are rational, okay? Proper fractions, improper fractions, all rational. All right? But there are some numbers that you cannot write as a fraction. And we're going to talk about some of those today. All right? Here's what we're going to do. We're going to go ahead and convert these numbers right now into fractions, all right, to prove that they are rational. Okay? So let's go ahead and do that right now. All right, how would we convert this number right here into a fraction? 3.4, yeah.
Start out with the big turn into a mixed number, which is 3.
3, all right, we're going to make a mixed number. And 4 over what? 4 over what, Hume?
10.
10. Now, you can simplify this. So we'll put a big arrow here, okay? And we can simplify this to 3 and 4 over 10 is the same thing as what? Caroline?
1/5.
Not 1/5. You're close. Yeah.
2.
2/5. Nice job. Okay. So that's rational. Okay. -2. Make this a fraction. Real simple. William, you just did this. Do it again. -2 over 1. Nice job. All right, moving on. 7.3 repeating. Okay, this is also going to be a mixed number. All right, we're going to have our 7, and then what can be the fraction? You can even just say the simplified version if you want. Savannah? Other way around? Nice job. Thank you very much. Okay, 6.125. If you want to look at yesterday's notes, you'll know that 0.125 is a fraction. Do you remember which fraction it is? William? Nice job. It's 6 and an 1/8. If you didn't know that, this 0.125 would be 125 over 1,000, and then you simplify. It simplifies to 1/8. Okay, what about this one? This one looks intimidating because there's just the bar of awesomeness, a negative sign, a decimal. There's that placeholder nothing business in the front. This is like, whoa, red flags, but it's not that complicated. Okay, what would you do here? Yep.
Can you just do negative 13 over 99?
That's it. Negative 13 over 99, and there is no way to simplify that because 13 is prime, so the only other number that goes into it is 1, and so there's no simplification here. So yeah, that's it. Negative 13 over 99. So even though that decimal looks scary, it's actually not too bad at all. Okay? All right. Now, when ordering rational numbers, convert them all to what? What do you think? What do you think I'm going to say? Hume. You know, that's a great guess, but that's going to be more work for you. We want to save you work. So that's a great guess. Anybody else want to take a guess? Right or wrong? They're good guesses. Andy.
Improper fraction.
Improper fraction would be another good guess, but that's still more work. There's an even easier way to do this. Jack.
Decimals.
Decimals. Yeah, so here's why. If you are going to compare fractions, you have to find a what? Typically. Yeah, you have to find a common denominator. And if you're comparing 5, 6, or even 7 fractions, you got to find a common denominator that works for all 7 numbers. Okay? That's a lot of work. That's a lot of that's a lot of equivalent fractions. And math was not designed to be more work. It's designed to help make less work. So, if you convert everything to a decimal, you can compare them so long as you know how to read decimals. So, let's go ahead and take a look at that here. Let's convert all of these to decimals. Okay? Do you know the decimal equivalent of 1/4? Leland? Yeah, 0.25. Okay? So I have 0.25. I have a negative 0.2. What is a negative 2 over 9? You should know this without having to use a calculator because it's over 9. Yeah.
0.2 repeating.
Yep, 0.2 repeating. So I'm going to just go ahead and put a couple of 2's there to show that it repeats. And I'll put my bar of awesomeness. And then 1.1. Okay. Already, we know which one is the biggest. Okay? So what is and we're supposed to do this from least to greatest. Okay? So if we have 4 spots to fill, 1, 2, 3, 4, let's go ahead and put the greatest one in at the end. What's the largest number, Savannah?
1.1.
Yep. As I do this, I'm just going to put a line through the number so that I don't reuse it. Okay, now, what is my next largest? We can work backwards if we need to. Nolan?
0.35.
Yeah, 0.25. Okay? Good. Put a line through it. All right, now, for some of you, if you're looking at these next two, you might be like, oh man, I don't know. They seem like very similar. But if you notice one difference, can really help with this. Okay, what would be my next largest? Caroline?
The 0.2 repeating.
Yep, 0.2 repeating. And the reason that the 0.2 is the smallest because what's out in front? Hume.
Negative.
It's a negative. Yep. So there we go. So we put them from least to greatest. Okay? All right. Compare the following values. Okay. Now, here we are. We're not exactly entirely sure what 3/5 and 4/7 are, but we can convert those into decimals. So instead of doing improper fractions and then finding a common denominator, just convert the fraction portion to a decimal. So somebody right now tell me what is 3/5 as a decimal. Nolan.
0.6.
It's 0.6. So negative 3.6. And then what is 4/7 as a decimal? So take 4 and divide it by 7. Okay, Ella. Hang on, keep going. It's 5, 7, 1. Keep going. 4, 2, 8. And then does it repeat? Okay. So this is going to be a negative 3.574128 repeating. Okay? Right? So you got to put the bar over all 6 digits. Okay? Now, that's a little overkill for what we're doing here, but it's still important to recognize that you can have a lot of digits repeat themselves. These are both rational numbers. So it's either it's going to end and it's going to repeat. All right, now the question is, and this is tricky because they're negative. Okay? This is tricky because they're negative. Which one is larger? The larger number is going to be closer to 0. 0. Nothing. Okay? Take a guess. Jack.
3.6.
Is not the larger number. Because it's farther from 0. Okay? The 3.574128 is closer to 0. It's the larger of the two values. Okay, if I were to draw a number line right now, and I have 0, -1, -2, -3, and then let's just say -4 is over here. And I know that's not spaced properly. But if I were to actually break this down, I'd have a -3.1, a -3.2, -3.3, -3.4, -3.5, -3.6, ... to 4. Notice 3.5 and everything that's 3.5 and some more is closer to 0. Okay, 3.5 is closer to 0. 0 is over here. Okay, it's closer to 0 than -3.6 is. So 3.6 is actually smaller than a -3.5 anything. Okay? So when you have negatives, sometimes it's the opposite of what you think. All right? Last problem. About 1/25 of a toad's eggs survive to adulthood. About 0.25 of a frog's eggs and 1/5 of a green turtle's eggs survive to adulthood. Which animal has the highest survival rate? Okay, so we have 3 values. 1/25, 0.25, and 1/5. Okay, and we need to figure out which one has the greatest survival rate. So that'll be the largest number. Okay, so let's convert all of these to a what first? Decimal. Okay, what is 1 divided by 25? Sam? 0.04. Did I write that correctly? Okay, great. Then I have 0.25. Okay, and then what is 1/5 as a decimal, Andy?
0.20.
Yep. All right, so I have my 3 numbers. Which one is the greatest number? Okay, Leland. Okay, so which creature is that? Okay, frog has best survival. Then what would have the middle survival? Okay, Ella? Okay. Green turtle would be second. Green tea is in second place. Okay, so the frog has the best survival rate. Green turtle has the second best. And what about the least survival rate, where it's like, not so good? All right, Caroline.
The toad.
Yeah, third best would be the toad. Okay, poor toad. All right. All right, very good. We're going to go ahead and stop it there, and we'll look at your homework.